So I want to talk a little more about correlations and some different possibilities that you'll see with correlations. And I'm going to continue with our silly example of the new intelligence test, or NIT. And there's two possibilities here. One is that as we get higher IQ scores, we see that the same people who get high IQ scores get high scores on the NIT. So a high score on IQ means a high score on NIT, so the person's there. A low score on IQ means a low score on NIT. And again, just like this is exactly what we talked about before, we get a pattern that looks like this. And we can draw a straight line through it that will approximate that pattern. It's not perfect. Some of the points fall off the line, but it is a pretty consistent looking relationship. So there's a relatively strong correlation there. What we would say also is that, and this is the main thing I'm trying to show you here, is that this is a positive correlation. By positive, what we mean is that the variables, in this case IQ and NIT, the variables change together in the same, and this is the important part, the same direction. Same direction, meaning that as IQ goes up, NIT goes up. As IQ goes down, NIT goes down. What would the opposite possibility look like? Well, it would mean if you got a high score on IQ, that you got a low score on NIT, right? So we would plot a point there. If you got a low score on IQ, you would get a high score on NIT. And this is different from the scenario we looked at before. And if we got a bunch of data from something like this, we would see that it would look like this. Meaning that in general, high scores on the IQ test predict low or are related to low scores on the NIT. So if we're to draw a line through this, it would go in this direction. And this might happen if, similar to an example they gave in the book, if, for example, with our new intelligence test, let's say that we were that the score was actually not the result of the number of answers they got correct, but then it was a result of the number of errors that they make. So the lower their intelligence, presumably, the more errors they should make. Then it would make sense for a high IQ to be related to a low number of errors or a low score on NIT. And that's how you could get this kind of relationship. This is called a negative correlation. So in a negative correlation, the variables change just like before. They're still changing together, but they change together in... Remember, changing together, this part is just part of the definition of correlation. There's a consistent way in which the variables change together. But in this case, they change together in opposite directions. And that is the key part, is this opposite directions versus same direction. So by opposite direction, you can see that if we go up in IQ, we get a higher IQ over here, that person is likely to get a low score on the NIT. So a higher IQ means a lower score on NIT, or a higher NIT means a lower IQ. So you can see these arrows are going in sort of opposite directions, right? Whereas these over here, these are both showing increase, right? Higher on one means higher on the other. On this one, higher on one means lower on the other. So this is one property that a correlation has. We call this property the direction of the correlation. We can also talk about the strength of the correlation. And that has to do with how closely these dots are clustered around the line. So if we had some other scores that were out here, Well, these scores are not fitting the pattern that we thought we had found. This guy right here got a high score on IQ and a high score on the NIT, which doesn't fit with this idea of there being a negative correlation. That means it decreases the strength of the correlation. So this becomes a weaker correlation. As the dots are clustered closer around the line, that shows a stronger correlation. So the strength of the correlation is also saying, let me write this down, this has to do with how consistent it is. In other words, does an increase of 10 points in IQ always predict exactly a 1-point increase in NIT? Or does it predict it most of the time pretty well, or does it not predict it at all? That is what we're talking about with strength. Now we can show this numerically by doing some calculations. In this class, we aren't necessarily going to get into great detail about the calculations. That's for a statistics course. But I want you to make sure everyone's clear on the concept. We can calculate what's called a correlation coefficient. This is often abbreviated with R. You'll see you'll see things in paper like R equals 0.89 or R equals negative 0.24. Those are the kinds of ways you will see correlations reported, and I want you to, more than being able to calculate that, calculating it is not a big deal, and hopefully you've had a statistics class and you've done this before, but if not, it's not that big a deal. What I want you to be able to do is to look at numbers like these and understand what they mean. So the correlation coefficient varies from 0, or sorry, not 0, that's wrong. It varies from -1 up to +1. In the middle here, this is where we would have 0. So it goes from -1 to +1 with 0 in the middle. What these numbers mean, -1, well, actually, let me say this. The negative sign, this is the direction. Negative versus positive tells you the direction of the correlation. So negative would be a negative correlation. Positive sign, a plus sign, would be a positive correlation. So if you see this guy right here, then you know we are talking about something like that. If you see this guy, then you know we are talking about something like that. So the neat thing about the correlation coefficient is it gives you a lot of information in a small space. And this is, by the way, this is usually reported to 2 decimal places. So you'll often see -1.00 or 1.00. And you will not usually see the number 1. And the reason why, and that's the next part that I want to explain. Let me grab a different color so I'm not just using white the whole time. This number, this shows you the strength. How strong was the correlation? How consistent was it? A correlation of 1 means that all of the points fell exactly on a straight line. So that would look like this, where we have everything perfectly straight. This would be a positive perfect correlation. So that is exactly what we're looking at right here. This is a positive perfect correlation. All of a particular amount of change in one variable is perfectly consistently related to a certain amount of change in the other variable. The variables change together in a perfectly consistent way. In contrast, we could have a perfectly consistent negative correlation, which would look like that. So that is what a -1 looks like. If we're in the middle, this is 0, this would be no relationship. No relationship. There's no correlation. There's no consistent covariating pattern here. The variables do not change together in a consistent way. If we were to, and I'm kind of running out of room, so I apologize that these scatter plots are so small. But if we'd had something like that, well, as we start to put the plot the data on our graph, as we record data about these people, we would find that, probably much to our dismay, there is no consistent pattern. People are just all over the place. That means there's no consistent relationship. There's no line that we can draw through this graph to indicate any kind of a pattern. Most things, obviously, are going to fall somewhere, if we're looking in a study, most things are going to fall somewhere in between. Either they're going to have no relationship, or they're going to fall somewhere between a perfect positive and a perfect negative one. So they're not, I didn't say that very clearly. Let me say that again. Most things either will show no relationship or close to no relationship, so something near zero, or something between 0 and 1, either in the positive or negative direction. What I'm trying to say with that is simply that very few correlations are going to be perfect. You're very rarely going to see a correlation of +1 or a correlation of -1, because very few things, especially in psychology, are so consistently related that you get that perfect, the very, very strong correlation. Much more often, you'll see things like a correlation of 0.6 or 0.4, which would fall somewhere, there's like a correlation of +0.5. Here's one of -0.5. Most things will fall somewhere in that sort of a range when you're talking about psychology, or even weaker than that. It's very hard to find a really strong correlation between variables because the variables are complex and messy. In psychology, we're talking about things like anxiety and depression and such. But hopefully that gives you a pretty good intuitive idea of what a correlation coefficient means. We've got the strength of the correlation. We've got the direction of the correlation. To make sure that that's clear, I will see if I can dig up some exercises for us to do so that we actually get a little practice looking at different examples of correlations that are going in different directions and have different strengths.